solution based on a not-to-flow deck switch with a flow focusing system.
Al único Dios verdadero. Hello everybody, my name is Leonidas. I really appreciate that you will be here. I feel gratefully with all of you that realized this conference. The students, teachers, or the person of different countries like Algeria, Tunis, Germany, or different countries. I am a Peruvian student, but in Peru I study mechatronic and mechanical. And then I traveled to Germany to study in the Ilmenau University, the career, the master in biomechatronics or biomechatronics. And in this moment I am going to expose something related to my studies that I finished in this university. The microsensors are an important field in this university. I am going to explain how a linear architecture that you can use for detect a special signal that have a low frequency using a switch optical and the flow focusing system. And normally, in the world, in the biological signal, we have the problem when we can detect for example, the signal that have too few frequency, like near to 1 Hz, and at the same time have a low amplitude near to the microvolts. For example, in the brain, the DC signal have this R in this group, and other signals in the brain are similar. The amplitude is near to 4 microvolts. The problem is that the sensor, for example, they get the accumulation of the error in the time when they take the measure of signal of low frequencies. And another problem is that the normal sensors are designed for capturing high frequencies, and the low are optimized for this. For this reason, we can use different technologies. For example, in the way of the optofluidic, the optical switch, and then we can use the RFID chips. And these technologies can help in this problem to, in the same way, the monolithic interferometer. I am going to explain this part, and then we can combine this, for example, in this architecture, to get amplify the signal, for example, in the order of the microvolts or nanovolts. For example, we can start with a with a monolithic fiber optic. For example, in this case, we have the Michelson interferometer. In a normal way, we use normally some kind of lens, but we can reduce the space using a monolithic interferometer. This system works with a laser signal that is the same that interferometer real. The distance in the both parts of the interferometer normally are the same, but we can change, for example, the distance of this part to get the difference between the both signal. And this monolithic sensor normally is have the measure related to 300 micrometer. In the university, they have developed this kind of technology, and they have proved. And then we have the optical switch. In this component, we have a drop that we try move this dropper using, for example, we put over the electric superface, and then we put a voltage, and we have a force that is generated with this formula. We control the voltage, and we can generate a force. This force permits that the droplet can move in this direction. And in the university, they have developed different projects related to this. For example, we can put this liquid between two in a little room with glass cover. And then, for example, we can do a switch, optical switch. This droplet we can move in both positions. For example, the light for example, is from this position in A to the N. But if we move the droplet, we can avoid that the signal continues in the same place. For example, in this way, the light signal is moved to another path, and we put the normal movement. And in the university, some groups have developed this optical switch. And then the semi-active sensors, it's important to know this. A little comparison between both sensors is that exists some sensor that have the name self-sufficient sensor. This sensor don't require energy of the environment, or they don't require electricity energy, because they generate its own energy, for example, using the environment. But another sensor are the passive sensors. These sensors use the signal that you are missing, and this signal at the same time is the energy that you use for the process. This is more interesting because avoid the use external energy. But in this case, inside, you have the semi-active that can use both processes at the same time. We need to know of the RFID technology that are presented in the books or in some products. These sensors or this device can use the energy of some machines that have the name the RFID, and this energy they use, for example, to work inside, to generate information, to process something. But this technology only works for milliseconds, because this energy only works in a little time. But using this, we can, for example, develop the some pressure sensor or oxygen sensors. They are useful for detect the presence or the rate of oxygen in some place or in some products that you are buying in the supermarket, and decide if are good or not good to eat or to buy. And for the energy, for example, you can use the energy that have in the environment. For example, using springs or sensor mass, they absorb the energy of the movement. Then the flow focusing system are important because you can generate little droplets, and you can control the diameter and the distance or the frequency of this. For example, we can use two elements, water inlet and the oil inlet, and we can use this system. And for example, in this part, we can see example of the diameter of this droplet and the spacing between this. And we need more information. We can check the parameters. For example, between the flow rate between the water and the oil. If we change the rate, we can change the droplet, the diameter. It's important to know this signal, how the droplet diameter or the flow changes in the time. For example, from 1.2 to 2 micro. This is the microliter per minute. This picture are important for know how change the diameter or the another parameters in the time. And then we need an actuator, that is the magnetro-hydrodynamic pumps. This is a little micro actuator that we use for move the fluid. We need two parallel walls, and we take in this part two electrodes and put a voltage, and then add a magnetic field and generate a Lorentz force. This Lorentz force moves the water in some direction. And then we can remember some information of the interferometer of laser that use the optic fiber. We have two arms with the same length or the same length, but we change the length of one of these. But in this project, we change not change the length, but we change the environment. Normally, the environment is a glass, but we change this environment in sometimes by water. This is an architecture that we can remember, but it's important configure all this together for get the exit of this sensor. I can explain more, but in this moment I say the conclusions. It's possible to combine different technologies in the microscale or nanoscale, develop in the nanoscale for develop more complex or innovative systems. This is a good way. For example, in Germany, they use this workshop to get more speed in the investigations. And then the integration process required for integrate different technologies not only modify the materials, modify the parameters, the inputs or the solutions. We need work in this part. And then it's important remember that the laser are similar, but this is the mean, or this is the thing that you can use for get the best option or for the best option for the visuals and of anything or of all the things that you want get emission. The light is a better option, is more pure, and you can, if you want get the best quality some process for missing or measure the some value, the temperature, the flux, or the movement, the long, the length, you can use the light. The light or the laser or another things that are similar. Yes, this is the final, and all these projects are of the University Technology Vietnam, and you can see the literature, and you can find more information. This is important, and the through child sign or book up on them. The light is important to us to find more information. Thank you very much.
Thank you very much, Mr. Leonidas, for your presentation and for the respect of the allocated time. Now, if any question from the assistants, please raise your hand. We have a question from Dr. Abshi.
Thank you for your presentation. The first question here is we talked about the moving droplets with the electrical field. Okay, so here you use only the weightability of the liquid, which is water, or the surface tension between the liquid and the glasses you said. Can you explain, please?
And yes, and you ask how we can use the water in this kind of process.
Yes.
Yes, again. Yeah, for example, the water, the droplet, is not require a superfice, and the electric can be an electric superfice, and the wetting coating for avoid that the water go to another place. This is for control the water. But we have this formula. For a better control, we have two glasses covered in the down part.
Talk about the surface tension of the liquid and the glasses.
Yes, yeah. That this is possible. Yeah, this is possible only in the microfluidics. In the normal fluidics, this property don't function. Well, can be microfluidics or nanofluidics.
So in this process, you use only the water, or you use another solutions?
Really, you can use different liquids. In this investigation is through the water, but you can use you can prove with different, but the water is cheaper. But for example, in the yes, but you can add some inks for changing colors. For example, black, and this is the base for develop some kind of tablets where you can read the books, but they are not a pixels. They are this kind of droplet. And they move the droplet or inside.
Thank you. Thank you. Another question, Professor Ibrahim.
Thank you. Excuse me, I am just curious. This kind of sensor has been proposed during COVID-19 to detect the virus infection of blood. Is this chip or the sensor that you propose is also applied for this kind of detection?
Yes, it's possible. For example, the virus in the blood are similar to droplets, but in nanoscale. And for example, if we use another system that is similar to I remember the cantilever. The cantilever. Inside the cantilever, we can put inside a fiber and a little tube. And in this tube, you have, for example, the blood, and inside the virus. And when this blood is running inside the cantilever, this gets a frequency of vibration. This vibration is according to the mass of the blood, and the mass of the blood increase when have more virus. If the virus have a little mass, I think nano, but in this case we use nanotechnology, not microtechnology. And in this case, is normally the vibration. You can get the voltage according to this vibration, putting an electrode in the end of the cantilever. This technology is used too for this analysis super fast in the picometer, because it's too, I think it's too, the precision is too much. But if you add more virus, the frequency changes. It's low because you have more mass. And the system, the voltage can change according to this frequency.
Bonjour, merci. Thank you, Monsieur Nathan. Donc, il est un petit peu près par le temps. Je vous remercie. Donc, on va passer à la dernière présentation avec laquelle on va clôturer les travaux de la conférence. Donc, j'invite Monsieur Rodman. Ah, Madame Rodman, je m'excuse. Donc, ce sera la dernière conférence de la session 3.